Hello everyone, Professor Ajvan here with another quick math lesson. Today I want to talk about how to simplify compound rational expressions. If you don't know what those look like, I have three examples for you. They are on your screen now. So if whatever you're working on, homework or otherwise, look like these problems, then this is the correct video for you. So let's go ahead and jump into it. So we can think of a compound rational expression as a fraction where the numerator of that fraction is some type of rational expression itself, and then the bottom, the denominator, is also some kind of rational expression. So in this first example, we have this numerator in red is a rational expression of 2 minus 1 over x, and the denominator is also a rational expression in the form of 2 plus 2 over x. And the way we want to deal with this is to kind of look at the top and the bottom separately. That's why they're color coded. All right, so we want to look at the numerator and we want to combine it into one single rational expression. All right, so I know that I can write 2 as 2 over 1. And I want to find a common denominator so that I can combine these because they're currently being subtracted. So the common denominator is going to be x. So in order to get the x underneath the 2, I need to multiply the top and the bottom by x. Right, this gives us 2x over x minus 1 over x, which we can now subtract because they have a common denominator of x. Right, so we get 2x minus 1 over x. But that's just the numerator. Right, this rational expression is the numerator of my compound rational expression. So what's going on with the denominator? All right, same sort of thing. I have 2 over 1 plus 2 over x, and I want the common denominator, which again is going to be x. So we multiply the top and the bottom of this 2 over 1 by x over x so that we can get 2x over x plus 2 over x, giving us a common denominator so that we can actually add these numerators. Right, so we add them and we get 2x plus 2 over x. So this in red, this 2x minus 1 over x, and this in blue, 2x plus 2 over x, are the top, the numerator, and the bottom, the denominator of my compound rational expression. So what I can do is put a line for the fraction here, and really we can put one at every step along the way. All right, so here, when we get to this point where we have a single rational expression in the numerator and a single rational expression in the denominator, what we can do is think about the denominator line between these two rational expressions as being division. Right? That's really what a fraction is. It's dividing the numerator and denominator. Okay, so we can rewrite this as the numerator divided by the denominator. And we know how to deal with this. We use that keep, change, flip strategy. So coming down here, we can have 2x minus 1 over x. We keep this the same. We change the division to multiplication, and then we flip the second fraction, x over 2x plus 2. So now I can combine these, right? Multiplying fractions is easy. We get to multiply straight across. However, we don't want to actually multiply them. We want to write them as the factors essentially being multiplied. Okay, and this is so we can simply cross out similar factors in both the numerator and the denominator to simplify. Right, so this would be 2x minus 1 over 2x plus 2. And to simplify completely, we should go ahead and factor the denominator by factoring a 2 out and having 2x minus 1 over 2 times x plus 1 as our final answer. Okay, so let's employ the same strategy but in a different example. Right, in this case, we have a single rational expression in the numerator already, so we're good there. But in the denominator, I have two rational expressions that we have to combine into one rational expression. All right, so let's put our effort in the denominator. Okay, we need, between these two rational expressions, for these to have a common denominator. Right? So the easiest way to find a common denominator is just going to be multiply each one by the other's denominator. Right? So I'm going to take this first rational expression, x plus 1 over 3, and multiply it by x minus 1 over x minus 1. And I'm going to take the second rational expression, 4 over x minus 1, and multiply it by 3 over 3. Right? The numerator, the 1 over x minus 1, is staying the same. It's already the single rational expression that we want. So looking at the denominator, right, the two rational expressions, I should say, in the denominator, they each have a common denominator of 3x minus 1, 3 times x minus 1, and we can now combine the numerators, right? I have x plus 1 times x minus 1 plus 4 times 3 is 12. Okay, and this is still a rational expression as our denominator, and we still have a 1 over x minus 1 as the rational expression in our numerator. All right, so before we do the rewrite this as division and keep, change, flip, and multiply and all that good stuff, I highly recommend that we simplify this numerator because there's currently a plus here. It's better if it's all written as some factors. Okay, so we can do that. Right, this numerator 1 over x minus 1 is going to stay the same. And we can quickly FOIL out this denominator and combine the 12, right? X plus 1 times x minus 1 is going to give us x squared minus 1, and then plus 12 is going to give us plus 11, all over 3 times x minus 1. Okay, so now we can take our numerator, the rational expression in the numerator, 1 over x minus 1, and write it as divided by the rational expression in the denominator, x squared plus 11 over 3 times x minus 1. Now we can use our keep, change, flip strategy where we keep this the same, 1 over x minus 1. We change the division, the multiplication, and then we flip the second rational expression to be 3x minus 1 over x squared plus 11. Right? And when we multiply these straight across, 1 times the numerator is going to give us the 3 times x minus 1. And we don't actually multiply these. Remember, we write them as the product of the two factors so that we can easily see that this x minus 1 is going to cancel and leave us with 3 over x squared plus 11. Right, and this 3 over x squared plus 11, there's nothing we can do to it to simplify. It's already in its simplest form. Okay, we have one more example to look at, and in this final example, both the numerator, the rational expression in the numerator, is already a single rational expression, the x plus 3 over x minus 3 in red, and the denominator is already a single rational expression, x squared minus 9 over 3x minus 9. Alright, so because it's already set up like this, we can go ahead and rewrite it as the rational expression in our numerator, x plus 3 over x minus 3, divided by the rational expression in our denominator, x squared minus 9 over 3x minus 9. And now we can use that keep, change, flip strategy, right? We keep this the same, change the division to multiplication, and flip the second rational expression. Okay, so we multiply straight across, but we don't actually FOIL or anything. We just put x plus 3 times 3x minus 9. And in the denominator, we have x minus 3 times x squared minus 9. Now, it might look like right now nothing's going to cancel, but we haven't tried factoring any of these terms. Okay, so if we factor this 3x minus 9 in the numerator, we now have x plus 3 times x minus 3. And in the denominator, we can factor the x squared minus 9 because it is a difference of squares, and it'll factor into x plus 3 and x minus 3. So from here, now that we have the numerator and denominator completely factored, and the numerator and denominator are written as the product of all of the factors, we can go ahead and look for common factors to cancel in the numerator and denominator. Right? So there's an x plus 3 in both the top and bottom. There is an x minus 3 in the top and bottom, leaving us in a simplified form with 3 over x minus 3. Right? So compound fractions, specifically with rational expressions, look kind of daunting, but if we take it step by step and apply the skills that we've already learned, they're really not too difficult to deal with. Thanks for watching. Good luck. If this video helped you, it would mean a lot to me with if I could get a like and a subscription. All right, thanks. We'll see you in the next one.